Morning to all. Myself, Dr. J.Jayapal, Assistant Professor, PG and Research Department of Computer Science, St. Joseph's College of Arts and Science, Autonomous Cuddalore. The subject data communication and networks. The topic is networking and internetworking devices. Generally, we call it the connecting devices. The connecting devices are categorized into the one is the networking devices, the another one is the internetworking devices. The networking devices are classified into the one is the repeaters, the another one is the bridges. The internet networking devices are the two major devices. One is the routers, the another one is the gateways. First, repeater. It is a networking devices. A repeater is an electronic device that operates on only the physical layer of the OSI model. A repeater allows extending the physical length of a network. A repeater is not an amplifier. It does not amplify the signal. It regenerates it. When it receives a weakened or corrupted signal, it creates a copy bit for bit at the original strength. A repeater must be placed so that a signal reaches it before any noise changes the meaning of any of its bits. So that is a diagram for the repeater in the OSI model. So that is the two devices are connected by the repeaters. So that is the 7 layer of the OSI model in the left hand side. So another devices, it's also the 7 layers of the OSI model. The layers are the physical layer, data link, network, transport, session, presentation, and application. Likewise, the another side we are using the 7 layers in the OSI model. So the repeater is it's only working on the physical layer alone. So that is one more diagram. So that is the devices are A and B, and then a right hand side C and devices. The both devices are connected by the repeaters. You see the diagram, the A diagram. A right to left transmission. The data is transferred from right to left. The weak signal, the corrupted signals are transferred from left to right through the repeaters. The repeaters, the strengthening the signal, we will get the actual strengthening of the signals. Likewise, that is the left to right. The corrupted signal is transferred from left to right through the repeaters. Again, we are getting the strengthening signal in the right hand side. So the next one topic is the bridges. A bridges operates in both the physical and data link layers of the OSI model. Bridges can divide a larger network into smaller segments. They can also relay frames between two originally separate LANs. The bridges contains logic that allows them to keep the traffic for each segment separate. It also provides security through partitioning of the traffic. So that is a diagram for the bridges in the OSI model. So that is a device A and then device B. The both devices are connected by the bridges. The device A, it's having the 7 layers of the OSI model. Likewise, the device B, it's having the 7 layers of the OSI models. The bridges, it's only working on the first 2 layers. They are physical and the data link layer. So that is a function of the bridges. So the A diagram, it is transferring the data from A to D and parallelly. It is segmented. It is splitted by the segment F and G. The A and D and F and G we are connected by the bridges. Likewise, if you want to transfer the data from A to G, the two segments are connected by the bridges. Okay, the mostly that is three types of bridges. The one is a simple bridge, multi-port bridge, and then transparent bridge. Simple bridge. A simple bridge, the most primitive and least expensive type of bridge. A simple bridge link two segments and contains a table that lists the addresses of all the stations included in each of them. In a simple bridge, the physical address must be entered manually. The installation and maintenance of simple bridges are time consuming and potentially more trouble than the cost savings are worth. So that is a diagram for the simple bridge. So simply we are connecting the two segments by the bridges. The multi-port bridges. A multi-port bridge can be used to connect more than two LANs. So here, that is, we are using the three LANs. The three LANs are connected by the bridges. So that is called the multi-port bridge. The last one is a transparent bridge. A transparent bridge is otherwise called as learning bridge. It builds its table of station on its own. Transparent bridges use a spanning tree algorithm or source routing to avoid loop. A bridge will be able to connect LANs using different protocols at the data link layer, such as Ethernet LAN to a token ring LAN. It addresses many issues which include frame format, payload size, data rate, and address bit order. Other issues such as acknowledgement, collision, and priority. Thank you.